So now let's look at this first question. What has been given to us? Integration of 2 minus tan x upon 3 plus tan x dx. And there is a value for it. Now you can see that in the integration, the answer that they've given us the answer in sine and cos format. So somewhat when we integrate this, we need to convert it in such a way so that in our answer also we can get sine and cos only. So first and foremost thing, what are we going to do? We are going to use or convert this tan x into sine x by cos x, and then let's see what our integration is coming about. So this can be written as 2 cos x minus sin x upon 3 cos x plus sin x. So this is what it is going to become. If I put my tan x as sin x by cos x, of course my cos x and cos x would be cancelled out from the numerator and denominator dx. So now if I look at this equation carefully, what I can do is I can use the formula of partial fraction that we had studied. What I'll do is I know what is the differentiation of 3 cos x plus sin x. It is minus 3 sin x plus cos x. So what if I convert the numerator into two different terms where one of them is the differentiation of this and the other one is the exact same this, and I can use lambda and mu for my constants. So what I'm saying is, since my 3 cos x plus sin x, this is the function in my denominator. If I differentiate this, what am I going to get? Minus 3 sin x minus 3 sin x plus cos x. This is what I'm going to get in my differentiation of this. So what am I going to write this entire function as? 2 cos x minus sin x. Now I'm converting the numerator in the differentiation format. So this I'm writing it down as lambda times of minus 3 sin x plus cos x. Now of course this just only lambda cannot simply equate this equation, right? So what are we going to do? We are going to add a mu and multiply it by cos 3 cos x plus sin x, which is in the denominator, so that now based on the values of lambda and mu, these two in terms would be balanced and would be equal to 2 cos x minus sin x. So from here what would I get? Minus 3 lambda plus mu. This should be equal to minus 1, and we should have 2 equals to lambda plus 3 mu. So from here, what is the value of lambda that we are getting? 2 minus 3 mu. If I replace it here, I would have minus 6 plus 9 mu plus mu is equals to minus 1. So we would have 10 mu is equals to 5. So mu would be equals to half. And from here, if I substitute this value here as well, I would get lambda as well equal to half. So these are the values of lambda and mu that I'm getting. Now I can separate my numerator into two different terms. So what would my integration now become? I would have this as integration. I can take lambda outside, so this would become half of minus 3 sin x plus cos x upon 3 cos x plus sin x dx. And here what am I going to have? Half of integration 3 cos x plus sin x upon 3 cos x plus sin x dx. So from here, this and this gets cancelled out directly. From here, if I take this lower function to be t, then I have dt on top basically. So if it is in that format, so it would become half of ln 3 cos x plus sin x, and here I would have plus half of x, plus there would be a constant of integration. So this is the final integration that I'm getting. Now what have they told us? That this entire function is basically equals to, this is equals to half of alpha x plus ln of beta sin x plus gamma cos x plus c. So of course, now since I have a c outside, I can keep it as it is. I can take half common from this function. So I'm getting my value of alpha to be 1. What would my beta be? My beta would be 1 and my gamma would simply be 3. So these are the values of alpha, beta, gamma that I'm getting. Now what have they asked us? I need to find out alpha plus gamma by beta. So alpha plus gamma by beta. So this would be equal to 1 plus 3 by 1, which would be equal to 4. So this is the answer that I'm getting. So this is how you could have solved this question again. If let's say this wouldn't have been quite possible for you, then what you could have done is you could have transformed tan x into its half angle formula. Then you would have 1 plus tan square theta below. You could have simply cancelled it out and write down your tan x by 2 st. However, that would have become a very complicated and different type of scenario. This one is pretty easy, where you simply try to convert your numerator into two different terms. One, which is the differentiation of the denominator, and the other one is the direct denominator itself. Let's look at next question. So what has been given to us in the question? Integration of sine square x into 1 minus cot x whole square. So to solve this integration, first what we are going to do is, let us multiply sine square x inside the bracket. So we would have sine x minus, this would become cos x whole square. Of course, cot x can be written as cos x by sin x. Sin x and sin x would cancel out amongst each other, and this is what we would get. Now from here, what I'll do is, I'll take cos x common. Or if not cos x common, what I'll do is, I'll divide the numerator and denominator both by cos square x. I hope you all remember we had studied a type of equation where you might have to divide by cos square x and then put tan x is equals to t. So that is what exactly we are going to do here. So this would become, if I take cos x common, so I would have integration of 6 sec square x dx upon tan x minus 1 whole square. So from here, I'll put tan x as t. So I would have sec square x dx as dt. So my integration would ultimately become 6 times of dt by t square. Sorry, t minus 1 square. Now how can this be written down? This can simply be written down as 6 times of 1 upon t minus 1 cube, and I would have minus 3 as well, minus 2. Sorry, this wouldn't be cube, this would just be minus 1, and I would also have a minus 1 multiplied above. This is what I'm going to get as my integration. Plus there would be a constant of integration as well. Now they've given us the value of integration at 0 is equals to 3. That means they're telling us what would be the value of constant term. So let us put, first of all, let us write down our I of x. It would be minus 6 upon t, which was tan x, minus 1 plus c. Now let us put I as 0. This would become minus 6 upon tan 0 is 0. So we would have minus 1 below. So basically 3 is equals to 6 plus c, and we would have c is equals to minus 3. So this is my c. So ultimately, what is my final I of x that I'm getting? It is going to be minus 6 by tan x minus 1 minus 3. This is my I of x. Now I need to find out I at pi by 12. What is pi by 12? Pi by 12 is nothing but 15 degree. And in trigonometry, we had studied the value of tan 15. Tan 15 used to be 2 minus root 3. So this would become 6 upon 1 minus 2 plus root 3 minus 3. And upon solving this entire equation, we are going to get our answer as 3 root 3. After taking LCM and then trying to rationalize the denominator, we would get this as our answer. So again, a very easy question based on the concepts that we had studied was to divide the numerator and denominator by cos square x and then put tan x is equals to t. Now let's look at this question again. In this question, we are going to use the same format. We are going to divide the integration that has been given to us by cos square x. So we would have a square tan square x plus b square, and on top we are going to have sec square x. So here we would have sec square x dx upon a square tan square x plus b square. So from here, if I put tan x as t, I would have sec square x dx as dt. So from here, what am I going to get? This would become dt upon a square t square plus b square. Now again, if I solve this, this is basically the differentiation of tan inverse. So this would simply become 1 upon AB tan inverse of AT by B. And here I am going to have a constant of integration as well. So this was again a formula that we studied earlier. So this is how we are getting this function to be. Now, one, now simply I'll substitute my T as tan X. So I would have 1 upon AB tan inverse of A by B tan X plus C. Now, if you look at the value that has been given to us in the question, it is more or less similar. Constant is there, our constant is there. Instead of 1 by AB, we have 1 by 12. That means 1 by AB is equals to 1 by 12 and A by B is equals to 3. So from here, what is the value that we are getting of A square? A square would become 36 and B square would become 4. So this is what we are getting. Now we have to find out the maximum value of A sin x plus B cos x. Now we had studied in our trigonometric functions the range of this function, right? So what used to be the range of this function? The maximum value of A sin x plus B cos x used to be less than equals to A square plus B square whole root under. So this is what we are going to find out. This would become root under 36 plus 4, which would become 40. And this is our answer. This is our maximum value, root 40. So again, a very easy question, again using the same concepts. So you can see in 2024 only, 6th April, the same question was asked based on the same concept. I mean, in 8th April also based on the same concept, and in 9th April also more or less a type of the same question was asked. So generally questions are asked only on this formats only, mainly in JEE mains. So the only thing is that it requires practice. So only if you have good practice and you remember the formulas, you can directly write down your integration and solve the questions. Let's look at this one now. The integral x to the power 8 minus x square, x to the power 12 plus 3x to the power 6 plus 1 tan inverse x cube plus 1 by x cube. So we need to find out the integration. So what I'll do is I'll assume my tan inverse x cube plus 1 by x cube to be t. So if this is t, that means if I differentiate this, I would have 1 upon 1 plus x cube plus 1 by x cube whole square into 3x square minus 3 by x to the power 4 dx is equals to dt. This is what I'm going to get as my dt. Now what if I take x by x to the power 4 as LCM, and then I'll take x to the power 3 here as well. So ultimately this would become x to the power 6 divided by x to the power 12 plus 3x to the power 6 plus 1 into 3x to the power 6 minus 3 upon x to the power 4. So this is what we are getting. This is dx is equals to dt. So from here, of course, if I cancel this x to the power 4, this would cancel this out twice. And if I cross multiply it, I can take 3 common. I would have x to the power 8 minus x square. That is exactly what we have in our numerator. So this would ultimately transform into dt by t. This is what I'm getting. So now if I integrate this, what am I going to get? Sorry, there would be a 3 as well multiplied outside. So I would have 3 times of ln t. And what was my t? Tan inverse of, sorry, I would not have a 3 here. I would have a 1 by 3 here. Basically, since I am taking 3 common, so my entire term into dx would become dt by 3. So I would have 1 by 3 outside. So I have 1 by 3 outside, and my t value that I had assumed it was tan inverse x cube plus 1 by x cube. So this is what I've gotten as my tan inverse. And that is exactly what we had to find out in the question. So plus c, a constant of integration. This is my answer. So this is how you can solve questions. Of course, you need to identify what function can you take as some other function, substitution, and then based on that, you generally solve your questions. So that was all about this chapter. Of course, as I mentioned earlier as well, I'm going to mention it again. You need to remember the formulas, the standard integrals, and practice questions of indefinite integration a lot. Now we'll be looking into definite integration, where we will have direct values which we can assign to any of our indefinite integration that we've gotten. That's all. Thank you.